Can you check if there's any sound on the Zoom thing? Just to be sure that at least my voice is coming through. It's the first time I'm using this thing. Yep. Stop it. Mute. You need to mute here. Okay. All right. Looks like we're getting less and less people here. I think next year I'm going to change this so that the background is black. Because it's just too bright. No, you prefer this? Okay. I don't know. I've been thinking that it's.
Yeah, it's too bright.
Yeah.
Especially in the morning.
Yeah, in the morning. Yeah, I was thinking like maybe I can have dark mode, light mode. I'm sure it's coming for the presentation. Why not? Yeah. Okay. Okay. I guess we can get started because I don't know if people are going to come or not, and they might actually be seeing this online anyway. So welcome everyone. So today we're going to talk about sensors, and this is actually a topic that I've been kind of doing research with for many years now, and it's still today quite a hot topic in terms of industry as well as research. So right now we are here, week 4, so 3 more to go. And then we have the spring break, and then you work on your project. So I will ask you to start thinking about your project. What are you going to do here? And with whom are you going to work with, if you're going to do it in pairs or teams. And send an email to Valerie and Kennedy so that we can start creating these group return boxes in Moodle or individual. So if you're doing it individually, you can submit the work individually the way it is. And then if you're a group, then only one of you needs to submit the work as you go. So we have these milestones. So here, it's basically just there so that you guys remember where you should be. We've had in the past cases where some teams that just did the work like 2 weeks before the deadline, and we don't want that to happen because we want to have a chance to at least see how things evolve, and if you're struggling with things, and don't just leave it for the last minute to do it. So that's the only thing. So just send Akko or not Akko, Valerie and Kennedy an email with whether or not you're going to do it alone and who are your team members if you're going to do it in pairs or groups. Okay.
So
Up to 4 people, no more than that. Okay.
I have same question.
Yeah. So yeah. I mean, ideally, you would have people who have complementary kind of expertise. So we've had groups that had someone that had an eye for design and someone who was good at sketching and stuff like this. And then basically together they work very well because they could plan things and, think about the project this way. Yeah.
How should we if someone wants to be in a group?
Yes.
How he or she should try to find the group?
So that's a good question. So in Moodle, we do have this Q&A section. It's like a forum. So just put a post in there. Everyone in the class will get the message. So just put there, I'm looking for teammates for this project, for this idea. So ideally, when you do that, you could either have an idea already in mind of what you want to do, and then see who wants to join you. So that is one way to do it. Or you just say that you would like to be part of the group if anyone's looking for someone.
I can create a thread so people can just search for teammates inside that.
Yeah, sure, that's a good idea. That's great. Yeah, so he will create like a new message there, and then you can just put there. Okay. Yeah. Any more questions regarding the project stuff? Remember, this is like you basically have 7 weeks to work on something that you want, basically, where you leverage everything we've been teaching in here, your new skills, and even new ones, because I mean, we don't cover everything. I mean, Ingrid is so big that ideally, by the time you get here, you will have more or less an idea of what you want to do during these 7 weeks. We also are realistic. I mean, in 7 weeks, you don't create a full-fledged application, so we don't expect like a perfect app, okay? So it's better to have something that works, that you can demonstrate that it works, within your known boundaries of what you know it works. Because we've had projects that in the videos, they look fancy and everything, and then when you run it, it crashes or it has a lot of bugs. So, I mean, but then in the video, you don't see any of that. And so this is where you need to be also, you know, self-aware that, you know, you have 7 weeks. Time passes really fast. And you also have other courses. You also have other things to do. So ideally, you would spend like, we say here, at least 2.5 hours, more or less, that you would spend every day, because that's the 5 credits that we have in here. But I know in practice that does not happen. You might spend maybe an hour, maybe half an hour. So some days you will work longer, some days you will work less. So just keep in mind that you should do at least 100 hours or so dedicated to this project. And so how you spread that out during these 7 weeks, it's up to you. But, and that's why we have these milestones, so that in a way, by the time you reach these, you will have done some part of those 100 hours, okay? This is just meant for us to also know that you guys are doing things and not just waiting for the last minute to do it. That's it. Okay. All right. Any questions? No. Okay. All right. So sensors. What's a sensor? To you, what do you think is a sensor?
It's like something that sends outside, or like collects data from outside world, and it can pass the data to the brain, and it can interpret that data.
I like your answer. So you mentioned the brain. And so in a way, we are a sensor. We sense everything that goes around you. There are devices that are sensors. So in the past, whenever I ask this question, a lot of people think about, you know, accelerometers and thermostats and things like that. But I tend to forget ourselves. We are a sensor. As a whole, we sense everything, or 5 senses at least, or 6 senses if you believe it, and extrasensorial things. But in general, a sensor is anything that can receive stimuli from the external. Okay. So if we think about a phone, we actually have nowadays a lot of sensors built in and packed into your phone. Here's some examples here. So you're most familiar with the accelerometer. So the accelerometer is the one that actually is responsible for orienting the screen when you flip it to the side. So that's just the accelerometer that's detecting where's the z-axis, which is pointing to the center of the Earth. And so as you rotate your screen, that value changes so that they know, okay, it needs to face this way, not that way. So that's how it works. The touchscreen is a sensor. If you think about it, the camera is a sensor. It captures light and retrieves that into pixels that you have as a representation of the image you just took. Magnetometer, GPS, microphone. There's a voice processor in your phone. So in the old days, when you talk with someone on the phone, there was a lot of noise. But nowadays, actually, there's a chip in there that reduces the ambient noise that is around you, so that when you're talking with someone, the person only hears your voice and not so much what's going on around you. I actually tested this the other day. I was talking with my mom using my phone, and my son was just banging cars and stuff outside. And I was talking with my mom. I was like, "Are you hearing that?" And she's like, "No. What's going on?" She actually couldn't hear the noise that was happening, which was my son playing with the fire truck or something. She couldn't hear it. I was like, "Oh, that's interesting." So that's one example of that. In the old days, there was a thing called the ambient temperature sensor that nowadays is actually part of the battery. They removed that sensor because it was not very reliable. But it still exists on the phone. The ambient light sensor, for example, measures the amount of light you have, and it adjusts automatically the brightness of your phone, like the screen. Barometer, humidity, these are just examples. In general, these are bundled as device functionality. So the screen orientation, the noise canceling, turning off the screen when you're on a phone call. So there's a proximity sensor in here that basically detects that your ear is close to it and the screen turns off so that it doesn't interact with the touch screen. Because otherwise you'll be talking with someone and you'll be doing some random stuff on your phone, right? The other thing is that nowadays people are exploiting the sensors to look into human behavior and context awareness, smart applications, fitness trackers, many things. So people, for example, looking at the barometer data, you can actually know if people are taking the staircase or not, or the elevator. And if they're walking, you can also detect how many steps, things like this. And then the sensors themselves, if you think about who receives this data, they actually can be used for informing other devices. So for example, if you think about a smart home where you have your phone and you have your TV, you can exchange data there. So sharing, communicating with other people, calls. So a phone call can also be seen as a sensor if you think about it, because you can report what is happening to someone else who's on the other side. So you are the medium through which the data goes. Photos, messaging, and apps and maps. So if we think about over time, in 2010, the Galaxy S1, so this is a Samsung device, old one, it only had 3 sensors basically: ambient light, accelerometer, magnetometer. Why these 3? So this would be to adjust the brightness of your screen. This would be to detect the orientation of the screen. And this one is actually to know where the north is. So then you can use GPS and maps, and then you can use this. And then they started adding other things like gyroscope and proximity. And then here is the pressure, so the touch pressure, RGB. So this is interesting. They used to have an LED. So some older devices, they had an LED to show you that you have a missed call. It would be green or red or something. Nowadays, not many of them have it. Like my phone doesn't have an LED to tell me what's going on. I need to go there specifically to see the screen. Temperature, humidity, that's also regarding the magnetometer in there. Heart rate and fingerprint. So some Samsung, I think S9 or something like that, actually had a heart rate monitor on the actual next to the camera that you would put your finger there. I don't know if it's the S7 or was one of these devices. According to that, it's the S5. So I guess it's about that time when they added this sensor on the actual device. And so manufacturers as a interest, they are adding more sensors to the phones because the phones are always with you, and as long as you have battery in there, you can use these sensors to either create new applications. So Samsung during this time, they were working on this Samsung Health application where they have like similar to Google Fit. They keep track of your calories and exercise and many other things. And so, if we think about how do they fit all these sensors in the device? Like if you think about the devices, they are getting bigger, I guess, but they also, some of them are really small. And if you think about it, like how do they cram all these sensors into the device and still have more or less a full day of battery life? Because the challenge here is like you keep adding new functions and new sensors, and then the battery keeps the same or somewhat the same. And so the big question here is how do you leverage all of these in an energy efficient way? And that's part of research a lot of the times. I did research on that area where we were trying to do batch processing of the sensor data to minimize as much as possible the impact that the battery has. So here's a video, it's actually created by Google, that actually shows you the anatomy of a phone, basically. And so I'll just play that for you.
We're about to enter another junction, one of Orange where neighborhoods are sealed under layers of copper and glass. You're about to enter.
Oh, hey there, welcome back. I'm Nat. I'm Love, and this is our 20% project, where we go find out about different Google stuff that we're curious about. And in this episode, we're taking apart a phone to learn what's inside of it and how that stuff actually works with our friend Ken. Dan works on the Android team, and his real job is helping developers make gaming apps. But in his spare time, he likes taking apart hardware. You're a pro at teaching, and then
I'm an amateur at breaking things.
Okay.
And taking it apart. All right. Start taking you apart. It's fine.
So when you open up kind of any phone, will it look basically the same inside?
It'll have similar components, and those components can be organized in similar ways. You've got a display, cameras, microphones.
There's a case, the battery, a SIM card slot, speakers, and a sensor that can tell whether or not a phone is near your face.
This is the gyro and the accelerometer.
They're both sensors that are useful for playing video games and fitness apps because they can tell your phone's movement. There's a motherboard, which is the main printed circuit board and does a lot of different stuff. A lot of phones also have daughter boards, which are an extension of the motherboard and can be all different shapes and sizes. Then there's also the fatherboard. Is there a fatherboard? No, I just made that one up. Yeah.
Almost every useful component you would see on a phone is actually on this board.
It looks like there's little neighborhoods on the board, like this is separated.
There are.
Separated.
suburbia.
So
Absolutely.
yeah, it's like
And
looking out from a plane window and seeing, like these little separate areas. So
course.
are they actually separate?
they are actual neighborhoods. That's a great way of describing it, actually. You can see both sides of the board have different neighborhoods.
Or something like Project Aura that has all the different components that you just slot into your phone. It's not like making one of those little neighborhoods just independent.
Absolutely. That's exactly what when you look at this, you can already see kind of like what Project Aura is trying to do. So one thing we're not able to take apart is this front display, and that's because this is all glued together.
But Dan explained that if we were able to take it apart, there'd be all these different layers of glass and insulating material and protective coating. And sandwiched between those layers are two very important layers. They have to be super thin copper wires, actually thinner than a human hair. There's a layer of wires that are horizontal and you carry an electric current, and they're called the driving lines layer. And then there's the layer of lines that are vertical that are called the sensing line layers. And together, they form a grid. And this grid has an electric charge. So basically, when your fingers get close to the screen, because they're good conductors of electricity, they disrupt the grid's electric charge. And the processor picks up on that, and it plots it on an XY axis. So it can figure out exactly where you're touching it, and can then route that information wherever it needs to go.
A phone is a really sophisticated computer combined with an enormous number of radios.
Not like the radio that you listen to in your car, but like a two-way radio, like walkie-talkies. So your phone can transmit data or it can receive it. So your phone has a cell phone radio, and that communicates with a cell tower whenever you're making a call. Then it's got a Wi-Fi radio.
And that's good for downloading big files or streaming video. It actually uses less battery because it has less distance to go.
It has a Bluetooth radio for connecting to maybe speakers in your living room.
If you've ever tapped your phone to pay, that's going to be using your NFC radio. It stands for near field communication.
Because it can only travel like 1.5 inches in range.
And last but not least, there's GPS, which of course is really useful for real-time mapping and in case you lose your phone.
And all those radios actually make it pretty tricky and interesting to design phones because you can't have them interfering with each other and they're all packed in there super close together. Dan, what are you doing?
I'm putting it back together, of course. Well,
How's it
seeing
going?
if I can. It's going pretty well. So yeah, just your average car.
What's your prediction for phones in the future?
This year, we're seeing a lot of cool stuff in terms of what we're doing with Project Cardboard and people using these phones as a basis for a virtual reality player. So you want to go and be somewhere else, you want to see the street view, you want to see it in 3D. You can use this with a couple of lenses and a piece of cardboard to be there. And I think that's just scratching the surface of what we're going to see in terms of phone technology and how it can provide you that sensory experience.
So what did you learn about phones from all of this?
It's a lot more fun when you actually know what's inside the things you use every day.
Yeah, it was interesting to learn how all these different things are laid out together. So there's probably as much, if not even more, design on the inside of the phone than there is on the outside. We wanted to thank you for.
All right. Yeah, so that's the gist of this video. Is actually maybe 4 years old. So the phone that they were disassembling was actually the Nexus 5. Project ARA that they spoke in here actually never came to be. It actually was canceled. So this was a modular phone that Google was trying to create.
And great capsules for your speed.
Yes, yes. Oh, great. It actually creates the subtitles, so you can now know what I'm saying. Great. So the project ARA was canceled, and the cardboard is also canceled. Stop reading that. I will turn that off. Okay. All right. I'm here, guys. All right. Okay, so that's kind of a summary, but I will go deeper a little bit more on the sensors in case you didn't catch all of them. So there's a set of sensors in Android which we call the motion sensors, and these are literally different sensors that measure different physical properties of the world. So one of them is the accelerometer, which basically measures the acceleration applied to the device, including the force of gravity. Its linear acceleration is the same way they exclude the gravity. So gravity always has the same value, 9.8 meters. So they just exclude that from the readings of the accelerometer. So you have a cleaner version of the accelerometer in there. Then if you just care about the gravity, so if you want to detect if the phone fell on the floor or something like this, you could actually use the gravity sensor. The gyroscope, it measures the rate of rotation of the device on its axis. And then you have the rotation where actually it detects the device in relationship to Earth, actually. It will tell you like what's the position of the device in relationship to Earth's reference. The gyroscope just detects the rate at which you rotate your device. Then we have position sensors. So these are basically computed using the gravity sensor as well as the barometer sensor and the GPS also. So orientation, magnetometer, proximity. So you actually can use this to make a metal detector. So if you use a magnetometer, if you approach your phone to something made of metal, actually the number of geomagnetic field strength will increase. So you can also do that. Proximity. So this depends on your phone. So some phones actually measure how close is after a certain threshold. So let's say if I have my hand here, it will say it's like 5 centimeters or something like that from the screen. But other devices, they also have it as binary. So they just say whether or not it's being obscured or not. So you'll just have 1 or 0, that's it. So these sensors could be used not just for taking phone calls, but you could also use it, for example, to know if your phone is in your pocket, right? Or it's facing down on a table. So if you combine the proximity sensor, let's say that, and the gravity sensor, you will know that the display is facing down, and you have the proximity sensor being triggered, so that means that the display is facing down. And then if you use accelerometer, you can know whether or not the device is moving, so then you know, okay, it's somewhere on the surface, and it's flat, probably on the table or something. Then we have an environment sensor. So like I said, the ambient temperature is very rare. Only like 2 devices that I know of actually had this built in. I actually owned the Magic, and I played around with the G1 long time ago, and they had this ambient temperature. So where I could actually just have my phone on the desk, and it would actually tell me what's the temperature in the room, for example. They actually removed that because the sensor was, first of all, very power hungry. It consumed a lot of power, but it's also not very accurate. So there was like 2-3 degrees difference between the actual value. And so this is like forget about it, it's not worth it. So now they actually replaced that with the battery. So the battery manager class in Android actually gives you the temperature of the phone. So that also allows them to, monitor whether or not the battery is getting faulty, or if it's overheating or anything like that. So light, it measures the amount of light you have in here. This is this light is interesting. So it doesn't really work as you would assume it would. It actually doesn't give you a precise measurement, but it will give you a relative number compared to lab studies. So they have trained a sensor where they have increased the light, and they have seen, okay, this is the real value, this is how much the sensor is giving, so this relates to that, which causes some issues, so that depending on who creates the sensor, the calibration might not have been the same. So then you can't really trust these values per se, but you can trust the value that it says it's right or not. And so this is how they have been using this. This is a barometer, so that's the air pressure. Did you know that the air pressure actually decreases whenever this rain comes? So basically, you can actually use your phone to tell you if you're going to get rain. So that's really interesting. Relative humidity, very rare. As far as I know, there's only 1 phone that has that, and that's like the Samsung S6 or something like this that has this humidity sensor in the actual device. I don't know if it's going to be a sensor that will stay, but it's very rare. And so the temperature, so that's the same as that. So now you can get that from the battery manager. What else? So I've been talking about the sensor manager. So the sensor manager is a class on Android that gives you an API, basically, where you can know what sensors are available on the phone. So depending on which phone you have, you will have a different set of sensors. So when you create an app, you can't assume that the other person's phone will have the sensor. So you need a way to check, is this functionality that I have implemented going to be useful for this device? And if not, is there an alternative way to provide the same features? And then listen for events. So the way Android works for sensors is that it's event driven. And that means that it will tell you whenever something changes. So if I have, if you're testing your phone, your data collection, and let's say you're collecting the light sensor, unless the sensor changes, you won't get any new value. So this is something you need to take into account when you're programming, because you might program something, and let's say you're doing the accelerometer data, but your phone is really still somewhere, and then you're like, I don't get any data. That's because your phone is not moving. So you need to move your phone and you start seeing the data. So you need to remember that. Otherwise, you're going to have headaches where you're wondering like, oh, I programmed this, is not working. Why is that? And it's just simply because the event is not being triggered. Okay. A good sensor to test things is accelerometer because it's so sensitive that even like micro variations of, you know, just the table shaking a little bit or you typing on the keyboard, it will make the sensor. So you will see things change. Today, at the end of the class, I will show you how to do this. But we're also going to do this in the class, in the lab, but I can show you how to do this. It's relatively simple. There's only a couple of methods that we need to implement. So which sensor do you care about and what happens when that sensor changes? That's it. So reacting to those, so that there's these two functions. So on accuracy change. So these sensors, like I said, they are not like scientifically accurate. Let's put it this way. They are okay for, you know, creating mobile applications and games and stuff like that. But the accuracy of the sensor is not scientifically validated. Let's put it this way, or certified. And so Google, they have like on the API, they have different states in which you can trust or not the values to a certain degree. So they have accuracy is low, medium, high, or unreadable and unreliable. So that means that, you know, if you're getting sensor data. So one way to manipulate this, for example, is, have you ever experienced this interface on Google Maps where it says the magnetometer is not accurate? It asks you to do a H shape with your phone so that it recalibrates the sensors. So that's that. So basically what is happening is that the magnetometer is reporting an unreliable value state. And so the Google says, okay, shake your phone something so that we can recalibrate. And that's it. And then this is the function that I said that the ARIP calls every time the value changes. That's it. It has new sensor data, so depending on the sensor, you're going to get different values. So if it's the magnetometer, you will get this microtesla value. If it's accelerometer, you get meters per second, X, Y, and Z. Then you have the accuracy, the sensor that generated the data, the timestamp in which the data was captured. So that because it's event driven, that means that the event might come later than the actual data that you have processing. Does that make sense? So the events are only triggered when things change. And so that means that due to certain delays, the actual sensor data might actually be timestamped a little bit later or earlier than the event timestamp. So the event is only triggered after the fact. Okay? And then the due date. So that's basically, it has a variable here that has a sensor event object, and in there there's all the data you need. Okay? And depending on the sensor, the data is going to look different. Okay? But there are the sensors like the GPS. I've been talking about this, so it determines your location based on your signal strength to the satellites above you, Wi-Fi. So you can also detect nearby access points. So if you think about Wi-Fi as a sensor, not just to get data, but it also can be used for that Bluetooth. So you can actually detect nearby devices if they're discoverable. Your own cell tower, like your own signal, like for phone calls and stuff, that acts also as a sensor because you can detect nearby cell towers. And this is how, for example, emergency response can know where someone is when they make a phone call. So they just look at, okay, what is the closest network tower that the person is connected to? So they have a sense of in what area are you calling from. So touchscreen, so like I said, the microphone, so you can detect ambient noise. You can detect also speech, so if are people talking or not. But therefore you can detect if there are people around you or not based on just the microphone. Camera, so nearby objects, markers, whatever. And then there are other kinds like the calendar, your email. So if you think about it, the calendar can be seen as a sensor where I can tell whether or not someone is busy with something or not, right? Yeah, so that's what we call a software-based sensor. So you can create these yourself. So here's an example of how do you interpret sensor data. So if we think about sensors, so you read the values that the sensor gives you, you make sense of it, and then you take an action. In general, that's the flow of this. The hardest part is really making the inference. It's really making sense of the data. So there's two ways to do that. One of them is to look at the sensor values that it gives you and make assumptions based on that. Or, actually, I said that preemptively. The dynamically inferred is basically you can use machine learning. So you can teach it what is that I'm doing, and that relates to this. So for example, a step counter. You can walk for a while, and you label that data, okay, this is walking, and then you can machine learning to detect that every time you find those patterns in the data. And so that's dynamically inferred, so you do code for that. And this one here is basically you can create thresholds, and then you just use that. So in general, I have this here. So in general, people don't see sensors much usefulness, I guess, when they do their projects, but it can actually be quite engaging experience when you actually do them well. So here's an example of an app that uses the gyroscope, the thermometer, it uses magnetometer so that it knows where you're facing, and then also augmented reality, so they see what they're doing. So let me show you. So what they have here, they're using computer vision, so they're having a marker on the, has anyone seen any of these before? These are becoming quite popular, especially not specifically for this, but in other things like augmented reality, board games. So there are now some board games that you play chess where you actually have the pieces that are augmented, where you can hold your phone and you can actually see the pieces fight each other as you eat the other player. So it makes things a bit more engaging for kids. My kids, they have like these, like learning about dinosaurs. And so it has cards, and then the cards, when you put your phone like that, you actually see the dinosaur in front of you. So my son is really excited about that because we're gonna get to see the dinosaur. Like what size was it compared to him? And you know, the Tyrannosaurus Rex was quite hilarious. So yeah, so this kind of things. But here's another example. Who knows ocarina? Okay, I see one person nodding. So basically, so here's another example where you can use a sensor in a very smart way. So this captures audio from the phone to measure a blow. So to know that someone is blowing air into the phone. And so they use a microphone, and then they measure, see how much noise is it making based on that. And if you want the source code, it's right there. Okay, to do this. But here's an example of how they've designed an app that leverages this sensor in a very creative way. Who knows this song? Okay. 2. Okay, very good. Many hours, man, many hours. The song is from The Legend of Zelda, so for those who have played Nintendo games, it's fun. All right. So another example is this one. So this was actually a project done by a fellow colleague of mine. I actually updated it to work with Kotlin, so there's the code there in Kotlin. So this was kind of looking at how you run, so using astronomer data and detecting jumps. So you could skip songs by jumping. So you would be running, and then if you want to, oh, I don't want, and you don't want to have to take the phone, you just jump, and it just switches to the next song. So the code is here where I got these. So these are actually intents from the actual Android music player that you can trigger on your phone, basically, on your app, where you can control the music playing. So if you start music, say using Google Play Music, and you have a sensor, let's say, looking at the accelerometer data, and you can see, okay, this is one step, a jump, step. So you can look at the data this way so that you can trigger responses on other apps. So in this case, we were just looking at the accelerometer data, you're running, and then if you jump, we skip to the next song. Okay? Yeah. So this is just to get your mind thinking about these things. So another example could be, for example, knowing whether or not if someone is alone. So you could look at nearby cell towers, Wi-Fi, Bluetooth, NFC, that's really close. Who's familiar with these here on the bottom? So Bonjour, Samba, MDNS, these are local network discovery protocols. So if you have a Wi-Fi, so if you're connected to Panol, for example, I can actually get a list of all the devices that are connected to the same access point as me. And that's like an open protocol. So if you know someone based on their device, because every MAC address has its own manufacturer, so you can actually pinpoint exactly what device is it that is being detected. So is it a Samsung S something or whatever? And so some people have explored that in order to know whether or not people are located in the same space. So in a meeting room or something like this. So Google has actually made a very nice API for this. It's called the Nearby API. So if you're interested in your project to determine if whether or not someone is around you or close to you, I recommend take a look at the documentation there. I've done an interesting application at home. So I have an Android TV at home, but Android TV does not have, it has a Play Store, but if I want to push an app that is meant for smartphones to work on the TV and it's not on the Play Store, I need a way to push that there. So I made an app for Android TV that I can know that I'm at home and I can push a file, an APK, to the TV without going through anything. So no, I don't need to transfer it somewhere else or anything. It just do peer-to-peer. So the Google Nearby also does peer-to-peer data exchange. So you can actually transfer files without even going through the cloud, which is great. Anyway, just poking your brain a bit so you can think about what you can do with this. So location tracking. So if you think about it, nowadays, GPS that is most common on everyone's phones is what we call assisted GPS. And this assisted GPS is nothing more than using Wi-Fi, Bluetooth, as well as GPS to know where you are. The thing is, GPS alone itself is very power hungry, and it takes time for the device to know and figure out what are the satellites that are above you, measure the distances and all of that. And so what Google has done is actually they have created a database of Wi-Fi access points. I don't know if you've seen this on the news. It was actually quite a big buzz, like maybe 5 years ago, that Google did this without people accepting to do this. So basically, their phones were used to create a worldwide map of access points for Wi-Fi without your even knowing about it. And so they just did that so that they could see that familiar access points, this is the location you are. And so they do that so that for you to get a GPS signal nowadays, when you open Google Maps or navigation, it's really, really fast. It takes like less than a second or maybe less than a minute. So that it knows where you are right now. In the old days, that could take 10 minutes, 5 minutes or more. And that doesn't happen anymore just because of this. So if we think that, you know, smartphones are a very personal device and it goes always with someone, and then, okay, you could think about Bluetooth as a way to know whether or not someone is here, right? We did a study where we actually found that 86% of the time the phone is within your arm's reach. So that means that accounts a lot of your time. Maybe when you're at home and you're charging it, you probably leave it somewhere. But in general, people just keep carrying their phone because they don't want to lose it and they want to be reachable whenever someone calls them, etc. And so we kind of, as in science or research, we started seeing it more as a proxy for humans. So if there's a phone, there's a person, almost like that. And so the marketing and advertising have started using these as a way for them to know how people, for example, explore a shopping mall, or how do they go shopping? Like, what is the sequence that they do? Why do they do that sequence? And these are things that happen behind the scenes. You don't even realize it, but this is how this kind of census can be used to also improve your experience when you go to a shopping mall or when you go to a grocery store. So where they know, okay, after this, normal people buy this. And so they can place the items in a order that seems logical to you. It's almost like they're reading the mind, right? Yeah. And so if you use Wi-Fi or Bluetooth, so BLE is Bluetooth Low Energy. It's a different standard that is meant for indoor positioning mostly. So it's about proximity, but not exact location. So there's still going to be like a margin of error, like 1 meter at least or less, so that they know that, okay, you are close to this, you are somewhere around this area, but they don't know exactly where you are. So my supervisor, he actually built, so he published this in 2010. So he did what we call a reverse engineer social network. And so this is him, that's Vasilis right there. And he was interested in knowing who are can his phone detect whether or not, who are his best friends? That's it. And so he created people's network. So people usually have on their Bluetooth name, their name. And so what he had here was everyone that he encountered, and then he just counted how many times in a day do I find this device around me. And so with that, he created a social network of his own social boundaries, basically. If you're curious, the link is here, so you can read it, how he did this. Since then, things have changed. So if he would want to do this again, it would probably not work because most phones actually nowadays are not discoverable. They're only discoverable during the pairing process, but then after that, they are hidden. And I think one of the reasons for that is just this. Okay, well, not this specific work. I'm sure other people have done this, but what I'm saying is that because of this personal relationship of the phone with the person that owns it, it becomes like a target for advertisement and all of these things, and so they decide to do that. I think Apple was one of the first ones to do that by default, and then Android now does that. So you cannot find someone else's Android device, but you can still find them on the Wi-Fi. So that's why I was saying that if you're connected to the same access point as me, I will know that you are there. So that works. So don't use Wi-Fi. I'm just kidding. But yeah, you can get that. So let's do some food for thought. So if you think about it, mobile phones are literally the most high-tech gadget today. If you think about it, it goes in your pocket. You can do a lot of stuff with it that it was just not possible like 5 years ago. And the whole class today was mostly for you to start thinking about sensors as a tool and as a source of data, basically. So you can do programmatically, so you can write software that analyzes the data and does something with that. Or you can just think about how you can convert that data into some sort of output. So the interaction. So the thing about ocarina, where you blow air, that literally just reads the sound level of the microphone and converts that into sound and music that you hear. And so this is another way for you to think about the sensors. So I've been talking about research and how scientists have been thinking about this. So this is work actually done here by Valerie. And so we're looking at how we could use sensors to monitor the progression of Parkinson's. And so we are using the phone sensors itself to do that. You want to talk about it, Valerie?
I don't know.
Okay. He's shy. Okay. So what we noticed is that there's a big difference in how people exhibit symptoms of Parkinson's when they are medicated versus not medicated. Actually, not medicated versus medicated. So this is someone who has not taken the medication because it's very noisy. But then when they take the medication, the signal is more clean. So there's no so many gaps in there. And so we had this idea of actually combining a bit of what I just mentioned before. So we have analysis of sensor data plus design. And so what we decided to do is, can we convert that into something that people that have Parkinson's would be happy to use on a daily basis and still have a sense of how well is the medication working for them and how is the disease itself progressing. There's no cure for Parkinson's, so that's the only thing we could do. But here's an example. So we have the game where the participant or the user had to keep a ball in the middle by holding the phone like this. So by measuring how they are able to keep that, we can detect the severity of the symptom. We had also this medication journal where they could actually just talk and say when they took the medication, they could type or they could just tap with one click, like the time and the date that they took the medication. We had reminders to help them, take the medication at a very specific time, because the efficiency of the medication depends on how reliable are they taking that medication also. So this is work that Valerie here has been doing for his PhD, and we have done a few studies on this. If you're interested in this, you can come find us. We can talk about this all day long. But yeah, so this is where we think that mobile computing can actually have an impact on people's lives. Here's another one that we did. So this is the CARE project, and this one was to help the nursing in elderly care homes. And so we made an app that allowed them to monitor the quality of life of people who live in these elderly care centers. Also allow them to detect things that they were not able to on the long run. So the thing is, elderly care is a very face-to-face kind of activity. And then nurses, they see things on a daily basis. They don't see it on a weekly basis or a monthly basis. And so when they started logging and having this data on, is someone eating? Is someone sleeping well? They could actually start seeing like, okay, someone is declining in health, someone is getting sick. We should get the doctor here. And in the past, they've done that maybe sometimes when it was already too late. And so this is kind of like our motivation in here. We have a video for that, so if you're interested. So we have sensors all over the place. We have these motion sensors here and location sensors. We have these in-grid boxes that literally just measure the distance between these devices. These are the size of a coin. These are really tiny. And we put them on the elder's shoes, or they have a wheelchair on the wheelchair, so we can actually detect where they go, how much time they have actual physical activity, how much time they spend together. And so these devices are also tiny. This is like maybe like this big. And so we made an app for them where they had their personal profile. So the nurses, in the old days, they had to go to a paper folder to get this information. They had to go to the computer to see, okay, what kind of medication they have and stuff like that. And now they have that on their pocket. So we did that. And it has things like what medications they have, health records, allergies, notes that the doctors might write whenever they come and visit, things like that they found, oh, he has a bruise here, we need to keep an eye on this. And so this is things that help the nurses do what they do in a more kind of supported way, because right now it's really tough. We did an experiment where we put this on the elderly home. We had 16 participants, 16 elders that actually used the sensors on their clothes, and we had the nurses, and it was nice. So they actually found that they do spend a lot of time with the patients. So we also measured how much time they spend with the patients. But we also found that they actually don't do much. Like the activity levels are so little then they start thinking like, oh, what can we do to change this? They can do some outdoor activities or anything. So this was different metrics. So amount of food they eat, the mood, and what else was there? So these are interviews with the nurses. If you're interested, we have a link right there for you to see. Yeah, so this is kind of, like I said, I've been working with sensors for a long time, but this is where I see how you can actually think about your project in a beyond, a to-do list. There's a lot of stuff that we can do when we think about a problem and how we could use technology to solve it. It doesn't necessarily need to be just smartphones. It can actually go beyond that. During my PhD, I was tired of coding the same thing over and over and over. So to implement how do you get data from accelerometer, it's the same, no matter how many years pass. And depending on the project, it's always still the same thing. You connect to the sensor manager, you get the data, you analyze the data, you do something with it. And so during my PhD, I built a tool for researchers to collect data, basically. This is a video from that. And when we made this video, we were kind of thinking like how we can take this somewhere else besides, academia. And so this is where this video comes from.
This is John. John is a healthcare professional. John wants to give the best service to his busy patients. This is Kate. Kate is a talented business executive. Kate is excited at the prospect of using personal technology devices to monitor her health and improve her well-being. But John and Kate can't work together. John loses time trying to understand new technologies, and Kate loses money buying expensive gadgets to wear out. But their problem is solved when you use Aware.
Yeah.
Aware is an app that enables its users to turn their smartphone into high-end health tracking instruments. The Aware framework is being developed by world-leading experts. It's privacy by design, and it's free for life. So this is how Aware works. First, download Aware on your smartphone from your trusted app store. Next, the app is configured to use your phone sensors and track your activity. Finally, you can decide to share your data with your doctor in real time. As a doctor, you can use Aware to monitor multiple users. Now, John and Kate can take full advantage of advanced technology and transform their practices to meet the evolving needs of the people they love and serve. Aware.
All right.
Intelligence in your pocket.
Enough advertising. Yeah, so it's interesting. So when I created Aware, I was thinking about different things. So I have had researchers that have put phones inside boxes and send them to the bottom of the ocean to measure the wave patterns at the end, like in the ocean. I've had patients who have used Aware to look at the chemotherapy side effects. We are doing it with Parkinson's, with the elderly care. We're doing it now with depression and bipolar disorder, schizophrenia, and these things. And so it's basically a platform for research that can have an impact in people's lives. So you have 7 weeks where you could think about this in a way that goes beyond this class. So to me, the best projects, in a way, or the best teams work when they have a bigger motivation than just passing the class. I mean, if you do the assignments and you try something, you will pass the class no matter what. So I think, to me, I feel more compelled, I guess, and more dedicated, I guess, to my work because I care about the work I do. And so in a way that's the kind of how I would want you to think about this, and not just because we have been easy this class, okay? So that's all I have for today. Let me show you how you use this sensor manager quickly, because it doesn't take that long. And so then you can see how you could use these sensors for collecting data. Let me just close this up here. I'm just opening Android Studio in here. Live coding. Last time it didn't work well. Let's see. Let's see if I do a better job today. Okay, so I'll just start a new Android Studio. You don't see it yet. Let me just go through the wizard here. Okay. Okay. All right, so we'll be using Kotlin. So it just created a project now. I just created like an empty activity this time. Okay, let me just bring this here. Okay. Okay, so if I come here, it's still processing, but anyway, so I'm just gonna open this here. Okay, so if we have an app and you want to get access to the sensors. So I said in the class that you need to use what we call sensor manager, right? So in this example, I'm just going to put it here on create, but ideally you should do it on resume. Like I said, the life cycle of the activity. Let me just put here on resume. The autocomplete is not working yet, so that's why I was thinking about doing it there. So we'll just create a variable value. Okay, let's call it sensor manager. let's just wait a bit, because otherwise we don't see what Android Studio gives us hints. Yeah, this is the problem with Android Studio. It takes a while. Well, it's only now because I just created the project. Like if I had opened the existing project, this would have been faster. Okay, all right. Let's see, I think it's still indexing. Once that thing is done. It's 9:20, so we still have time, so it's okay. I wonder if I can already do this. Nope. It's telling me to wait a bit. I should have opened this before the class, then it would be just running on the background. Lesson learned. So how familiar are you with finding documentation? Because sometimes, you know, especially in Android, I guess our first instinct is to go to Google and find how do you do this. But and actually, Google has done a phenomenal job in documenting their stuff, like really ridiculously meticulous. And I can give you an example of that while we wait. This is ready, but I will show you what I mean. Let me just open here Google Chrome. All right, so okay, so if we go to developers, Android, you can see it's there already because I spent my day there. But you can search for different things. So I can search, for example, sensors. And you can see it already gives me like a bundle of things that I might be interested in. So let's see the sensors one. So it has an overview here of the sensors. So you can go there. And it has a bunch of sensors here on the left. So position sensors, environmental sensors, the stuff that I was talking today, basically. And it also gives you code hints, like how do you do these? So for example, if you go to the sensors, documentation is there. Let me see, introduction to the sensors. So the different kinds of sensors, what do they measure? How do you get the data? So there's the sensor manager that I mentioned. So you can use this class to create an instance of the sensor service. So let's do that. So if I go back to my code, so if I come here and I do sensor manager right there, so that's the one that I will need. So there's no new. So there's a squiggly C in there. So if you don't know what it is, so you can just press Control Q. Not here, a sec, here. It just tells me that this is part of Android, so why is it complaining? It says cannot create. Okay, so that means that there's something else. Yeah, I know why. Okay. So this is system service. There. Sensor service. Okay. And all right. Okay. So this sensor manager is actually managed by Android operating system. So that's why we need to do it this way. Okay. So now on the sensor manager, we need to tell it what kind of sensor do I want the data from, right? So if we go to sensor manager, So there's this kind of utility function, which is get default sensor or get the sensor list. So I did tell you that not all the phones have all the sensors you would expect. And so you can actually query the device for the sensors that it has. Or you can just say, give me the default one. Because sometimes you actually might have more than one sensor that does the same thing in the same device. So that can also happen. So this is how you would get, for example, the accelerometer. So you could just do this. So this returns the sensor, which let's say here. Okay. So literally I just asked Google to give me an instance of the sensor accelerometer. And now how do I get the data? So now you just do accelerometer. Second. So here you can get different information like who is the manufacturer of the sensor, etc. Where's this thing? Okay, so here, register listener. So I can register the listener for the sensor. My neck is killing me. So you can create a sensor listener. So that's the callback that will be done, and you pass the sensor that you just created before, and this function is going to call that callback whenever it changes. So actually, Satu just came here. So there's an idea for a project for you guys. I will stop here because we will talk more about this tomorrow too. So Satu, would you want to talk about the project now? Yeah. Let me just quit here. Just a second. Yeah. Okay. Let me see if I can present. Where do I present this? This is a good question. Let me see. I'll just put it here. What the? Okay, let's see. Okay, and I think it's somewhere here.
Slideshow there.
Yeah. All right.
Okay.
Yeah.
So we have this kind of need for iPad application that could be used in dog training. And dogs are really, really accurate sensors for smelling. But you cannot just plug them in and record the measurements to your computer. And actually this, what dogs do, it cannot be automatically detected either. So you need in a loop a human who interprets the dog's behavior and understands what dog is doing and what is meaningful and what you want to record from dog's behavior during training. And in our applications, the dogs are used for detecting pancreas cancer from these samples from the patients. And the dogs are trained so that you have several test containers, and when dog comes and smells, it is not just that what container the dog marks as a positive one, but you also need to know, did the dog pass some containers without smelling? Where did the dog start? from which end or in the middle, and the dog repeats some containers several times until was sure that this is the one. So many things during training are important for the trainer. And currently the trainer is marking everything on a paper. And then when you want to analyze the results, it takes extra time when you have to convert the markings to Excel or something. And they would like to have an application where they can click which container the dog passed or selected. There are several things that you need to record for each container, and well, those details will be told later. But the thing here is that if you want to use dogs as a official medical device, the training has to be 100% sure, so that you have to be able to come back and analyze and be sure that there's no room for
Mistakes.
not mistakes, but just what is this when you suddenly win a lottery? So lucky, yeah. There's no place for luck.
Yeah.
So that you have to be absolutely sure that when dog says this is the one, it will be the one, and not just that you misinterpreted the dog's behavior. So that you have to be sure that dog wants to tell that this container is the positive one, and that's why it is really important to train them in a very accurate way. But if you are interested in this real need application, you can contact Denzil or directly me. The one that has been working with this project is now on sick leave, so she cannot be contacted directly, but I can be a middle person here. And if you want to know more, we have some links where you can. Denzil probably will.
I'll put this on
distribute this. So
on
you
Moodle.
have some links where you can check what kind of activity this dog training is.
It's actually being recorded too, so. Ta-da!
Well, anyway, I would like to find a group that would take this application as a project here in this course, and it has to be iOS, so iPad application.
Or web-based.
Web-based, but not Android. And there are some requirements, of course, for details, how it should look, and let's see how it goes. But if we find a group, then let's start discussing more.
Yeah. Yeah, I told them to send today, starting from today, to start sending us like what group is it going to be and what project is it going to be. So this could be one option for anyone who's taking this class. So the idea, like Sato was saying, is to make a web-based kind of application where they can tag what the dogs do and how they did it to detect the cancer sample. And they just do these for training. So it's not, I guess with the way you came across that this needs to be 100% is like, I mean, the dogs are the ones being trained, the ones going to be evaluated, not you. So for you, you're just creating a tool that is better than pen and paper, because right now it's just almost impossible to do that.
And sometimes you have to do things really quickly, so that you just cannot find where's that button, but it has to be a really simple thing. We have had some sketches about how it could look, so you don't have to start from scratch.
But anyway, maybe we should put here your email